welcome to week 8. We skipped week 7 since we had spring break. This week we're taking a look at methods for measuring behavior. Really what we're looking at are measurement tools in research. Now, measurement tools are something that may seem really simple and easy and obvious, but there are actually quite a few details about the way that you gather data that can drastically affect what your results are going to be. The sections for this chapter first are using tests to gather data. Then we're going to look at surveys or questionnaires of attitudes and personality. And then we're going to take a brief look at observation. How do we gather data when we are watching people do things? Finally, we will have a brief section discussing how to put together a methods section. So part of the activities for this week will be putting together your methods section for what you want to do or what you will do for your own research paper. So to give you an idea of just how much the tools you use can help you out in discovering interesting things in research, I've put together a very simple example here. So imagine you have a test or a survey where you want to manipulate the format to have it give you different bits of information. So let's say that on the survey you have a very simple question. Who would you rather have with you on a desert island? Now, if you give your participants a choice between these two people, just show them the two faces and say which one do you want, it's very easy for people to make a decision. But what information are you getting there? Think about this. If you give a person uh, just a split second moment to give their answer, they may just choose based on some unconscious bias. Maybe they'll choose male or female. They won't be able to take in very much information about the faces, but they might be able to take in male or female, or they might be able to take that the person on the left definitely has a more positive demeanor than the person on the right. If you give them a little bit more time, they'll take in more information. So I bet you with just a little bit more information, they'll be able to take in the facial uh, features and the quality. Maybe that the person on the left is prettier than the person on the right. Not sure, honestly, which one would be considered prettier. And then after a while, if you give them, say, 30 seconds to a couple of minutes, or as much time as they want, then they might make a decision based off of the appearance of the people. You know, which one of these two people seems like they would know more about survival on a desert island or be more useful. I don't know, but you can imagine that just based on the amount of time you give people, you can get drastically different responses, and that those responses can mean drastically different things about the people you're testing. Another way you can mess with the format of a test is actually to give folks an interesting set of answers to answer with. So in this case, we have a series of 6 faces, and these faces are actually composites designed to be somewhere on a neutral scale for male and female, but also you can make the male face more feminine or more masculine, and you can make the female face more feminine or more masculine. So regardless of how scientists put these faces together, you can imagine that being given a 6-point answer choice here allows people to choose whether they care more about masculinity or femininity, and get fine grain answers on, well, how much masculinity or how much femininity is desirable for the desert island scenario, or whatever question you're particularly asking for. It could be that people prefer more feminine men and more masculine women, or they prefer something that's almost in the middle. Not sure, but you can imagine the drastic differences in findings you can get just by manipulating the format of a test. So let's talk about what things we can do to tests or we can mess with tests, how we can mess with tests to get interesting responses or useful research data. So just to be clear, a test is an assessment of someone's knowledge or abilities, and the results are used as dependent variables most of the time. You can divide tests into 2 pretty reasonable sections. Achievement tests, which are just seeing, okay, how well does a person know a certain amount of things? Good example of achievement tests are going to be standardized tests like you take in order to advance grades in school. Another example are going to be vocabulary tests. And the cool thing about a vocabulary test is that they can often be used as proxies for intelligence. So, yes, intelligence tests have a place and there's worth to them, and you're never going to be totally able to replace an intelligence test with just a test of vocabulary, but turns out that in most cases, the more vocabulary you have, the higher your intelligence. And you can kind of imagine why that makes sense. Um, with more intelligence means you have better memory, means you're better able to work with context clues to figure out what vocabulary is. It means you're probably also more well read or more familiar with the rest of the world, so it's not a bad proxy. Another way to think about tests, or another subsection of tests, are going to be tests of ability, those designed to assess how well people can do things or how well they can learn things. Another way we can cut up tests is into recognition and recall tests. So a recognition test is going to be how well do people recognize answers, and multiple choice tests are going to fit that bill really well. A recall test is going to be can you remember an answer? Can you produce an answer on your own? And that's going to be more akin to fill in the blank tests or essay tests. Now, what's the difference between these two types of tests? It turns out that recognition tests are a lot easier than recall tests. If you ask just about any student, they'd rather take a multiple choice test than a fill in the blank test, and that's partially because those recognition tests are easier. But you want to think a bit more deeply than that. Consider this. Can you draw a penny? Can you draw the uh, Wendy's logo? Or can you draw the Starbucks logo? I would really encourage you to stop this video now, give it a shot, and then check your answer. Turns out that for the most part, people suck at drawing logos, but that's because logos are not designed to be recalled, they're designed to be recognized, and it's really easy to recognize those logos for what they are. So consider that different types of information need to be uh, recognized, and different types of information need to be recalled. And so, depending on the type of test you're giving your participants, or depending on the type of information you're looking for in your participants, you might consider giving them recognition or recall test. Another thing that can affect tests are retention intervals. So a retention interval is simply how long do you give people to wait before they can take the test to see if they remember stuff. So in this case, we have some data that show that when you give people a test of memory 1 hour after they learn the information, they recognize the information a lot better than they're able to complete the fragments. So what does that mean? This was a test where they were given a series of words to remember, and the way they answered the words was either to pick them from a multiple choice group, or they got the first 2 or 3 letters and they had to fill out the rest of the word. And so after 1 hour of attempting to memorize the list, recognition was a lot better than fragment completion, filling out the remainder of the word. But a week later, recognition was way worse compared to fragment completion. Now, there's a lot of different reasons why this might be, but it's not hard to imagine that your memory for information is going to be different 1 hour after you learn it compared to a week after you learn it, or even months or a year. And depending on the type of learning you're trying to research, you're going to want to make sure that your retention interval makes sense for that learning. So if you're learning for a school period, maybe 1 to a couple of months. If you're learning, if you want people to retain information or learn it just for a few moments, say for example like on a manual or instructions on an elevator, or something simple that people use quickly, recognition would be more important. Alright, another thing to be wary about or be aware about in tests are a concern of cultural bias. So what is cultural bias in a test? Well, it's the idea or the problem that tests can be designed in such a way that they can have different results for people of different cultures or races or ethnicities or genders or ages or whatever. The idea being that, say for example, an intelligence test designed in the United States might have completely different scores for people from India or people from Australia or just a different culture, or even a test of intelligence designed in a upper class by an upper class member of the United States might be less useful or less accurate for someone of a lower class. And so there's actually a pretty funny example here of this. Let's see, I already gave the description. In the 70s, IQ was a really big thing, and it's important to note that IQ is no longer something that we assess and that we really consider. It's actually a kind of a defunct measure of intelligence. There's better, more accurate forms of intelligence tests now. But at the time, IQ was really big, and so one of the problems was that it was culturally biased. Vocabulary was a big part of that IQ test. Unfortunately, the test was developed by an upper class, affluent Caucasian person, and so there was this concern that it was culturally biased. And so if you gave that IQ test to young or lower class or black people, in this case, they had much lower test scores. But it's not that they were less intelligent, it's that the test wasn't designed very well. It wasn't designed to assess the intelligence of everyone equally. And really, that wasn't necessarily intentional, but it's so easy to make that mistake. Because how do you know that you've made a perfectly ambiguous test? To demonstrate this point, this gentleman here, let's see, his name was Dr. Robert Williams. Sorry, I don't remember his name. Developed a test called the Black Intelligence Test of Cultural Homogeneity. It's got a funny acronym if you put that together on your own. And the idea was that it would be a test of intelligence for young black children who lived and grew up in ghettos. The way it worked is that those children, or really anyone taking the test, would have to identify the meanings of 100 slang phrases used in black ghettos in the 1970s. And not a big surprise, those children got very high scores on the test. They did really, really well. But people who did not grow up in black ghettos did a lot more poorly. And so it's a very clear example of a test that was designed to be culturally biased, just to kind of highlight the concern that intelligence tests could be culturally biased. This gentleman, I believe, is still actually active in the research community, and I would strongly encourage you to check him out if the Black Intelligence Test of Cultural Homogeneity makes sense to you and is interesting. I've also got another video here about intelligence testing. This one is about the people in Australia and intelligence tests for the native population of people in Australia. They call them Aboriginals. There's a wonderful video. I'll make sure to make this or link it and put it up on our class website so you can access it more easily. It does a wonderful job of showing how two different intelligence tests may be needed, or different intelligence tests may be needed for different populations of people, just because those different populations have a different focus, different values, different things that are important to them. Okay. So what else can we work with on on tests? Well, so when you take a test as a student, how do you know that the questions on those tests are actually valuable for making sure that you have learned something in the class? Well, when I'm designing a test, I don't know that. I try to put together test questions that are useful and that are applicable and that would assess whether the student has learned the material in the class, but it's hard to do that, and really it's not possible to do it perfectly on your first go. But we can do something called item analysis to check whether the test does actually have questions that are good questions, questions that assess your knowledge of the topic, or maybe questions that don't fit in, questions that I taught well, or that the teacher taught well, or that maybe weren't taught very well in the class. The way an item analysis works is a little bit complicated, but to put it simply, we have here an example of questions 18 through 28 from a test that I gave a few years ago. And so they each had an answer for A, B, C, or D, and you can see the answer that was correct highlighted in gray here. So in this case, for question 18, 27 students answered B, which was the correct answer, and a couple students answered A or D, which were not correct answers. Now on the right here, we have a form of an item analysis which shows a number, and the higher that number, the better that question was in the test. What do we mean by better in this case? What is a better item analysis score? The higher the number, the better grade a person got if they also got that question right. So what this says is that if you got a B, you probably did pretty well on the test overall. So if you answered this question correctly, you probably did pretty well on the test overall. Over here, this question, everyone got this question right. So it doesn't have a very good item analysis score, because if everyone got this question right, it doesn't have any good way. It doesn't show who is better, who knows more, who got better scores than other people. And there are actually negative ones here. This one has a minus 13. What this means is that the people who got this question right on average had a slightly worse score than the one person who got it wrong. Now in this case only one person got it wrong, so that's not necessarily a very good judgment, but you can see how this score would be useful. If the scores, if the item analysis scores are really low, that means that no one question did a good job of demonstrating a student's knowledge of the material. If the scores are really high, that means all of the questions did a good job of assessing a student's knowledge of the rest of the material. So we can kind of check whether each question is useful or not. Another way that this is useful is this can actually help catch cheaters, because if you get a really good grade and you miss questions that everyone got right, but you get questions that everyone got wrong, that's going to tip off your instructor that you may have cheated. Okay, just a couple more little things here on how we can mess with tests to give us information. This is a confusing screen, but it's useful in understanding the idea of response time. When we do research into how people learn, and a lot of more specific things about psychology, psychologists will often use response time as their dependent measure. Response time is literally just how long it takes for a person to respond in a given moment. So in this study, people were shown a series of 4 squares for each hand, and they had to press a button corresponding to each one of those squares. So in each trial or each go, they would see the light, and so they had to press this button. And then on the next one, they would see this light, so they had to press that button. Over here we have the response time data for that. On the x-axis is how many tries they'd have, from 0 up to more than 2,000 tries. And then on the y-axis we have how long it took them to respond. This is in milliseconds, so 500 means half a second. 0 means 0 seconds. 100 means a tenth of a second. And so you can see in terms of the blue circles, as the trials went on, people got faster and faster and faster, and after about 2,000 trials, they were able to respond in less than a quarter of a second every single time. That's only true, however, if there was some sort of sequence, like you had to press left pinky, right pinky, left thumb, right thumb, some sort of sequence. If the buttons were totally random, there really wasn't very much learning to do, so it's not like people actually got much better at pressing the buttons over time. In that case, the response time can really show us, are people learning? It's not as if they're going to get the answers right or wrong more often as they're going on, but they'll respond more quickly, and that's really useful in checking and doing research that involves simple, high-speed skills. Okay, last point for this section. We can also use dual tasks to assess how people are doing on a test. A dual task, pretty simply, is when people have to do 2 things at the same time. So thing 1, you press the left or the right button depending on which one you're supposed to press. Thing 2, you count how many times you see blue squares. Now, why would you do a dual task like this? You can imagine that pressing the right button is not too hard, and counting the number of blue squares is also not too hard. But doing them both together will actually provide your researcher with a good measure of how much people are able to do at the same time. You can add things in here like stressing people out, or make them walk while they do the job, or make them talk. And that will show how much of a loss in attention people have from doing those multiple different tasks. So you can see if they get a wrong count for the number of blue squares, the number of blue squares that they missed would be a pretty simple proxy to say, okay, they missed 5 out of 10 blue squares. That means that this task required half of their attention, or at least half of the attention that would be needed to count those blue squares. I hope that makes sense. It doesn't necessarily have to make sense. You don't really need to remember all of these different little things, as long as you understand what they are. So a dual task, doing more than one thing to see how well they can do those 2 things at the same time, or to see how much attention it takes to do those things. All right. In the next section, we'll take a look at questionnaires and surveys about attitude and personality. See you in a bit.